Hello again, guys. We are here in 11.1 talking about lines and angles. And now we're in the three-dimensional plane, so we get into some things that we maybe haven't covered before. We're going to first start talking about parallel lines. Parallel lines are on the same plane, so what you're used to, and never intersect. They run parallel to each other, so we normally give the example of like railroad tracks. Something like that are parallel. Skew lines are non-coplanar, not parallel, and do not intersect. So think about maybe the line that would be of a stop sign compared to the line down the middle of the road. And then parallel planes are two planes that run surface to each other. So a good example of that would be the two floors of your house. So here we have the planes ABCD and the plane EFGH parallel to each other. Go ahead and try this example in finding parallel and skew lines and planes. So if we look for segments parallel to AB, we can look in the same plane for the segment CD, or we can look in a different plane like EF or GH, and actually depending on which way you look depends on what plane they're in. So then when we come over and look for segments skew to CD, I'm actually probably going to change color here. So if we're looking for things that are skew to CD, remember skew means that it will never intersect and they are non-coplanar. Now we're looking for two pairs of parallel planes. So we actually have 6 different planes over here because there's 6 faces that make up any rectangular prism. So go ahead and make sure you have 2 pairs at least of parallel planes. So the first pair of planes that I choose here is ABCD and EFGH. If you were to imagine them extending out forever, they would never touch. Make sure you have your second pair. Another you can think of is ABFE with DCGH, or you could do ADHE with BCGF. Then what segments are parallel to BCGF? Go ahead and make sure you have that. So BCGF, BCGF, that rear plane. We could think of AE or DH, multitude of segments that could be drawn, but those are 2 easy ones. And there you have it. So then go ahead and try this example. We want 2 lines that are skew to EJ. Pause the video and make sure you can figure this out on your own. We want different plane, so if you think of lines like AF, that's a problem because they're in the same plane, but if I use the point A and B, I can make a line that's in a different plane and would never intersect EJ. I could even do like BH along that way would be a skew line in a different plane because it's going a completely different direction in the 3-dimensional world. So we want parallel to this plane right here. So a line that I see to begin with is CL, DH, or GB, because they're all going the same direction as that plane. Think about if you were to flip it and just look at what would be above it. You might think about the lines across the back here, CD or LH, but because I have no indication of angles here, I'm going to go ahead and say that those would not be parallel unless you knew something else. So when we talk about 2 lines being intersected by a transversal, that's the line that intersects the 2 lines, and every time you have a line and an intersection, you will have 4 angles formed. So when you have 2 lines with one transversal, we actually form 8 angles. So then we talk about our special angle pairs as either being interior or exterior. So my interior angles here fall inside the 2 lines, so that would be 3, 4, 5, and 6, and my exterior angles fall on the outsides, 1, 2, 8, and 7. So then these interior and exterior angles have even more specific names. So now we start talking about whether they're same side or alternate. So if we want alternate interior angles, we have to look on the inside space and then on the alternate sides of the transversal. So 4 and 6 could be one pair, or 3 and 5 could be another pair of alternate interior angles. Same side interior, however, we look on the same side of the transversal, still on the inside of the 2 lines, so we have 4 and 5, or we could match 3 with 6. Corresponding angles are on the same side of the transversal. So here if I start with 1 and 5, they're both on the left of the transversal and in corresponding position, so meaning above the other line. So 1's above L and 5 is above M. So go ahead and see if you can figure out the other 3 pairs of corresponding. And there you go. Alternate exterior angles moving on. We are exterior, so we are looking at 1 and 2 or 8 and 7. And then you want alternate sides of the transversal. So we would have 1 and 7, or we could say 2 and 8. Please make sure you have all of this written down before moving on. Go ahead and try example 3 on your own, finding the alternate interior angles for the figure involving M and N. I can go ahead and use 2 and 6 because they're on the inside of the lines, or I can use 3 and 7 also because they're on the inside on the alternate sides of the transversal line R. Then when we move on to 4, we want to use the above figure, the same one, to talk about 3 pairs of corresponding angles. So we're going to have to use the same figure. So if I look at angle 2, that's above the transversal to the right of my line. So I look above the transversal to the right of my line. That would be angle 4. Then if I look below the transversal to the left of my line, I can go below the transversal to the left of my line. And then we can also, let's say, go below the transversal to the right and below the transversal to the right. So we'd have 5 and 7. Moving on to example 5, there's going to be a few different pairs, so I'm going to stop the video and type them out. So go ahead and pause this and make sure that you can list the same side interior angles. So try to look at all the different situations that happen here with line pairs and transversals. So the first 2 same side, had a typo there for a moment, so sorry about that. If we look at the lines D and E here, then a transversal line of B, we can have the same side interior to be 5 and 6 because they're interior of the 2 lines and same side of the transversal. Some people might ask if we could talk about the angle 7 in here and the angles 3 and 4 as same side. If the transversal was C, the 2 lines were A, B, they could be same side interior, but then this would be an angle pair to form another angle, so we would not really want to do that. So then if we look at alternate exterior angles, we can look at the transversal C and have the exterior of the line pair A and B. That is all I really have for you guys on 11.1, so please make sure you've worked through the entire Pearson module and then go ahead and try your practice work. Let me know if you need any help, and I'll see you guys in class.